Dear students, in the previous class we had a general introduction to statistical thermodynamics. In this video, we will have a discussion on Maxwell-Boltzmann statistics. The Maxwell-Boltzmann distribution concerns the distribution of an amount of energy between identical but distinguishable particles. It represents the probability for the distribution of the states in a system having different energies. Today, we will have a discussion on Maxwell-Boltzmann distribution law. നമുക്കറിയാം സ്റ്റാറ്റിസ്റ്റിക്കിൽ 3 ടൈപ്പ് സ്റ്റാറ്റിസ്റ്റിക്സ് ആണുള്ളത്. വൺ ഇസ് മാക്സ്വെൽ ബോൾട്സ്മാൻ, സെക്കൻഡ് ഇസ് ബോസ്-ഐൻസ്റ്റീൻ, തേർഡ് ഇസ് ഫെർമി-ഡിറാക്. അപ്പോൾ ഇന്ന് നമ്മൾ കാണാൻ പോകുന്നത് ഫസ്റ്റ് ടൈപ്പ് ഓഫ് സ്റ്റാറ്റിസ്റ്റിക്സ് ആണ്, മാക്സ്വെൽ ബോൾട്സ്മാൻ സ്റ്റാറ്റിസ്റ്റിക്സ്. അതിൽ മാക്സ്വെൽ ബോൾട്സ്മാൻ ഡിസ്ട്രിബ്യൂഷൻ ലോ ഡിറൈവ് ചെയ്യാൻ പോവാണ്. ഓക്കെ, so suppose we have n number of identical and distinguishable particles with total energy E. So total number of particles is n and total energy is E. And let n0 be the number of particles in epsilon 0, n1 in epsilon 1, ni number of particles in epsilon I. Now if we are considering the degeneracy of the energy levels, okay, let Gi be the degeneracy of epsilon I. Then the total number of ways in which ni number of particles may be distributed in Gi levels is Gi raised to ni. Okay, here Gi is the degeneracy of the ith level and ni is the number of particles. So therefore, the number of ways of distributing n number of particles in groups of ni in various degenerate levels. ഈ ഒരു ഇക്വേഷൻ നമ്മൾ നേരത്തെ കണ്ടതാണ്, ഫസ്റ്റ് ഇതിൽ കണ്ടതാണ്. How different particles, identical and distinguishable particles, can be distributed in groups of ni in various degenerate levels. Here we are considering the degeneracy also. So the equation will be W equals n factorial into the product of Gi raised to ni divided by ni factorial. That is equation 1. Now apply logarithm. Okay. So log W is equal to log n factorial plus summation. ഇവിടെയും log കൊടുക്കുമ്പോൾ log Gi raised to ni minus log ni factorial. Let this be equation 2. Now apply Stirling's approximation. So according to Stirling's approximation, log n factorial equals n log n minus n. So using Stirling's approximation, we can write log W equals n log n minus n plus summation log Gi raised to ni can be written as ni log Gi minus, again you have log ni factorial, so minus ni log ni minus ni. Equation 3. Now just rearranging n log n minus n plus summation ni log Gi minus summation ni log ni plus summation ni. Now summation ni means it is the total number of particles, which is capital N. So in this equation, instead of summation ni, you can write capital N. Therefore log W equals n log n minus n plus summation ni log Gi minus summation ni log ni plus capital N. Okay. So here you have minus n and here you have plus n. So you can write log W equals n log n plus summation ni. Here log Gi minus log ni. So which can be written as summation ni log Gi by ni. Equation 4. Now you have to differentiate both sides with respect to ni. That is d log W by dni equals d by dni of summation ni log Gi by ni. See the first term, it is n log n. Capital N is the total number of particles, which is a constant. So differential of this n will be 0. That's why we have not written the first term here. Okay. So d log W by dni will only be equal to d by dni of this second term. So summation ni log Gi by ni. So differentiate and you will get summation log gi by ni minus 1. Or you can write d log w is equal to summation log gi into dni minus summation log ni dni minus summation dni. Let this be equation 5. Now you have to find out the probability of predominant configuration. Okay. So in order to find out which configuration will be the most probable, we have to take the condition that d log w is equal to 0. Okay, so please remember this condition since w denotes the thermodynamic probability. So in order to find out the probability of the predominant configuration at which w has maximum value, we are taking the condition that d log w equals 0. So in equation 5, put these terms equal to 0. That is d log w equals 0. So you can write 0 equals summation log gi dni minus summation log ni dni minus summation dni. Or summation log gi dni equals dni into summation log ni plus 1. Equation 6. Now again consider summation ni equals capital N. Let this be equation A. Also summation ni epsilon I equals capital E. That is the total energy. Let this be equation B. Now differentiating equation A and B, we get summation ni to differentiate what do you get? Summation dni equal to 0 because summation ni equal to capital N which is a constant. Appo summation dni it is equal to 0. Adine equation 7 ennu mark cheyidittundu. Okay, so summation dni equal to 0, equation 7. Now next differentiate equation B. We have summation ni epsilon I equals E. So summation ni into d epsilon I plus summation epsilon I into dni equals 0. So here summation ni d epsilon I equals 0. That means summation epsilon I dni equals 0. So you have equation 7 and 8. Okay. Now taking equations 7 and 8 and we have to multiply it with an undetermined constant. There is two constants, alpha dash and beta. Multiply equation 7 with alpha and equation 8 with beta, which are two constants, and then add to equation 6. That is this equation. ഇങ്ങനെ ചെയ്യുന്ന മെത്തേഡിനെയാണ് Lagrange's method of multiplication എന്ന് പറയുന്നത്. And these constants are called Lagrange's undetermined multipliers. Again, this is a method used in mathematics. So these constants are called Lagrange's undetermined multipliers, according to which constraints are multiplied with undetermined multipliers, undetermined constants, and added to the differential of the function that is given to maximize. So accordingly, you get 0 equals summation log gi dni minus log ni plus 1 into dni plus equation 7 is summation dni. So you have to multiply it with alpha dash. So that is done here, alpha dash into dni. The summation term is commonly written outside. So alpha dash into dni plus equation 8 is beta epsilon I dni. Now dni is common. So you can write summation log gi dni minus, here you have log ni plus 1 plus alpha dash plus beta epsilon I, and 1 plus alpha dash is written as alpha here. Okay. So we multiplied with the constant alpha dash. Here you have 1 and alpha dash. So 1 plus alpha dash is written as alpha here. So log ni plus alpha plus beta epsilon I into dni. That is summation log gi minus log ni minus alpha minus beta epsilon I into dni equals 0. Now we have two terms. ഈ ഒരു equation equal to 0 ആണെങ്കിൽ either dni will be equal to 0 or this term log gi minus log ni minus alpha minus beta epsilon I will be equal to 0. But we have a restriction on the system that the total number of particles is a constant, the total energy is a constant. That means the variation in ni, that is the variation in the number of particles, are independent of each other and need not be equal to 0. That means dni need not be equal to 0. Then which term will be 0? Log gi minus log ni minus alpha minus beta epsilon I is equal to 0. That means summation log gi by ni equal to alpha plus beta epsilon I, or you can write gi by ni equals e raised to alpha plus beta epsilon I, or there is also another way of writing ni equals gi by e raised to alpha plus beta epsilon I. This equation gives the most probable distribution among various possible energy states for a system at constant energy. Okay, so you have ni equals gi by e raised to alpha plus beta epsilon I. This is the fundamental equation which represents the most probable distribution. Now you have two constants alpha and beta. So we have to find out the value of alpha and beta, and that will complete the Maxwell-Boltzmann distribution law. Now what is Ni? Ni is the number of particles in each energy level. Gi is the degeneracy. Epsilon I is the energy of the ith level. Now first we will find out what is alpha. Okay, so we have the equation Ni equals Gi by e raised to alpha plus beta epsilon I, or you can also write Ni equals Gi into e raised to minus alpha plus beta epsilon I. That is Gi into e raised to minus alpha into e raised to minus beta epsilon I. And now give summation to both sides. So you can write summation Ni equals summation Gi e raised to minus alpha into e raised to minus beta epsilon I. Summation Ni is capital N, that is capital N equals e raised to minus alpha into summation Gi e raised to minus beta epsilon I. Now this term, that is the summation of the term summation Gi e raised to minus beta epsilon I, is a constant for a given system, which is called the molecular partition function. And this is a very important term, molecular partition function, represented as Q. And it is a characteristic of a system. It is a constant for a given system. Okay. Therefore, you can write the total number of particles N is equal to e raised to minus alpha into Q, instead of summation Gi e raised to minus beta epsilon I. So e raised to minus alpha into Q, or e raised to minus alpha equals N by Q. So we have written Ni equals Gi into e raised to minus alpha into e raised to minus beta epsilon I. So instead of e raised to minus alpha, write N by Q. So you get Gi into N by Q e raised to minus beta epsilon I. Therefore, you can write Ni by capital N equals Gi e raised to minus beta epsilon I by Q, or Ni by N equals Gi e raised to minus beta epsilon I divided by, instead of Q, write summation Gi e raised to minus beta epsilon I. Ni by N represents the fraction of the total number of particles in the ith energy level, and it is known as the probability of finding the particle in the ith energy level. And this is called Maxwell's distribution law. Now next, you have to find out the value of beta. So to find out the value of beta, we are again starting from the first equation. W equals n factorial product of Gi raised to Ni by Ni factorial. log w കൊടുക്കുക. Stirling's approximation കൊടുത്തു കഴിഞ്ഞിട്ടുള്ള ഇതാണ് എഴുതിയിരിക്കുന്നത്. log w equals n log n plus summation ni log gi minus summation ni log ni. Now we have ni equals capital N gi e raised to minus beta epsilon I by q from the equation for alpha. So therefore apply log to this equation. Ni equals capital N gi e raised to minus beta epsilon I by q. ഈ equationൽ log apply ചെയ്യാം. So you will get log ni equals log n plus log gi plus log e raised to minus beta epsilon I. So that will be minus beta epsilon I minus log q. Okay. Therefore log w equals n log n plus summation ni log gi minus summation ni into നമുക്ക് ഇവിടെ log ni എന്നാണ്. അപ്പോൾ log ni ക്ക് പകരം ഇത് എഴുതി log n plus log gi ഇതിൽ നിന്നുള്ള ഈ വാല്യൂ എഴുതി. So inside the bracket log n plus log gi minus beta epsilon I minus log q. So that is n log n plus summation ni log gi minus നോക്കൂ ഇവിടെ summation ni log n ആണ്. So which can be written as n log n minus again summation ni log gi plus summation ni beta epsilon I plus summation ni log q. So here you have n log n minus n log n, ni log gi minus summation ni log gi. So the remaining will be these two quantities. So you can write summation ni beta epsilon I plus summation ni log q. Summation ni epsilon I is capital E. So you can write log w equals E beta plus summation ni is capital N. So E beta plus n log q. So you got log w equals E beta plus n log q. Now we know that the third law of thermodynamics is related to the thermodynamic probability by S, or you can say that the entropy is related to the thermodynamic probability as S equals K log W. And this is also known as Boltzmann-Planck equation. So we have S is equal to K log W. Therefore S equals K into, instead of log W, substitute E beta plus n log Q. So we have K E beta plus Kn log Q. Now differentiate with respect to E at constant volume. That is dou S by dou E at constant V equals K into dou by dou E of E beta plus Kn into dou by dou E of log Q. Here K and N are constants. Okay. So K into dou by dou E of E beta plus Kn into dou by dou E of log Q. Which is equal to K beta plus Ke into dou beta by dou E at constant V plus Kn into dou by dou E of log Q will be 1 by Q dou Q by dou E at constant V. Now the partition function Q equals summation gi e raised to minus beta epsilon I, which is equal to g1 e raised to minus beta epsilon 1 plus g2 e raised to minus beta epsilon 2 plus etc. Differentiating this with respect to beta, we will get dou q by dou beta equals g1 e raised to minus beta epsilon 1 into minus epsilon 1 plus g2 e raised to minus beta epsilon 2 into minus epsilon 2 plus etc. So we can write dou q by dou beta equals summation gi e raised to minus beta epsilon I into minus epsilon I. Again we have summation ni epsilon I equals E, or summation epsilon I will be equal to E by summation ni, that is E by capital N. So you can write dou q by dou beta equals summation gi e raised to minus beta epsilon I into, instead of summation epsilon I, you can write minus E by N. So that is equal to minus E by N into Q. Okay, so please remember we have written the molecular partition function which is differentiated with respect to beta. and you will get in this form. Now summation epsilon I is written as E by N. So dou Q by dou beta will be minus E by N into Q. Now substituting in dou S by dou E at constant V. So dou S by dou E at constant V will be equal to K beta plus Ke into dou beta by dou E at constant V plus Kn by Q into, we have dou Q by dou E, which is written as dou Q by dou beta at constant V into dou beta by dou E at constant V. Now here substitute for dou Q by dou beta, which is minus E by N into Q. So that is written here. So we have Ke into dou beta by dou E here. Here also N and N will get cancelled, Q and Q will get cancelled. So here minus Ke dou beta by dou E. So the remaining will be K beta. So you got dou S by dou E at constant V equals K beta. Now again from thermodynamics, we have the Maxwell's relation dE equals TdS minus PdV. If the volume is constant, dV equals 0. This term will not be there, only TdS. So you can write dou E by dou S at constant V equals T. Therefore, dou S by dou E at constant V equals 1 by T. Here we have dou S by dou E at constant V equals K beta. From the Maxwell's relation, we get dou S by dou E at constant V equals 1 by T. That is, K beta equals 1 by T or beta equals 1 by KT. So we have got the value for beta, which is equal to 1 by KT. Therefore, we can modify the Maxwell's relation as Ni by N equals Gi e raised to minus. We had beta epsilon I. Instead of beta, write 1 by KT. So e raised to minus epsilon I by KT divided by summation Gi e raised to minus epsilon I by KT. Here Ni is the population number and this equation gives the most probable distribution. T is the temperature and K is the Boltzmann constant. Now suppose we have two energy levels, epsilon J and epsilon I. So the number of particles in this level, if you take the ratio Nj by Ni, will be equal to Gj e raised to minus beta epsilon j divided by Gi e raised to minus beta epsilon I. Each of these case denominator is the partition function, which is a constant. So we have written only these two terms, only the numerator terms. So we have Nj by Ni equals Gj e raised to minus beta epsilon j divided by Gi e raised to minus beta epsilon I. That is equal to Gj by Gi e raised to minus beta epsilon j minus epsilon I, which can also be written as Gj by Gi into e raised to minus delta epsilon Ji divided by Kt. Okay. So from this we can say that the distribution of particles between any pair of energy levels will depend only on their energy of separation, that is delta epsilon and also temperature. Since Nj by Ni equals e raised to minus delta epsilon by Kt. So the distribution of particles between any two energy levels will depend only on the energy of separation and temperature. And this is known as Boltzmann distribution law. If the states are non-degenerate, then we will not have this term Gj by Gi. Then Nj by Ni will only be equal to e raised to minus delta epsilon by Kt. Okay. So this is the Boltzmann distribution law.